Mysterious yellow glass in Libya traced back to extraterrestrial impact. Geoscientist Elisaveta Colavela explains how she and her colleagues unraveled the mystery of the yellow desert glass. The Great Sand Sea Desert stretches over an area of 72,000 square kilometers, linking Egypt and Libya. And if you find yourself in a particular part of the desert in southeast Libya and southwestern parts of Egypt, you'll spot pieces of yellow glass scattered across the sandy landscape. It was first described in a scientific paper in 1933 and is known as libya-desrt glass. Mineral collectors value it for its beauty, its relative rarity, and its mystery. A pendant found in Egyptian pharaoh Tutankhamun's tomb contains a piece of this glass. Natural glasses are found elsewhere in the world. Examples include moldavites from the Reeds crater in Europe and tektites from the Ivory Coast, but none are as rich in silica as the libya-desrt glass, nor are they found in such large lumps and quantities. The origin of the glass has been the subject of debate among scientists for almost a century. Some suggest that it might be from volcanoes on the moon. Others propose it's a product of lightning strikes, fulgurites, glass that forms from fusion of sand and soil where they are hit by lightning. Other theories suggest that it's the result of sedimentary or hydrothermal processes caused by a massive explosion of a meteor in the air, or that it came from a nearby meteorite crater. And now, thanks to advanced microscopy technology, we believe we have the answer. Along with colleagues from universities and science centers in Germany, Egypt, and Morocco, the writer says, I have identified libya-desrt glass as originating from the impact of a meteorite on the Earth's surface. Space collisions are a primary process in the solar system as planets and their natural satellites accreted via the asteroids and planet embryos, also called planetismals, collided with each other. These impacts helped our planet to assemble as well. Under the microscope, in 1996, scientists determined that the glass was close to 29 million years old. A later study suggested the source material was composed of quartz grains coated with mixed clay minerals and iron and titanium oxides. This latter finding raises more questions, since the proposed age is older than the matching source material in the relevant area of the Great Sand Sea Desert. To put it simply, those source materials did not exist in that location 29 million years ago. For our recent study, a co-author obtained 2 pieces of the glass from a local who had collected them in the al-Jaouf region in southeastern Libya. We studied the samples with a state-of-art transmission electron microscopy TEM technique, which allows us to see tiny particles of material 20,000 times smaller than the thickness of a paper sheet. Using this super high magnification technique, we found small minerals in the glass, different types of zirconium oxide, ZrO2. Minerals are composed of chemical elements, atoms of which form regular three-dimensional packaging. Imagine putting eggs or soda bottles on the shelf of the supermarket, layers on top of layers to ensure the most efficient storage. Similarly, atoms assemble into a crystal lattice that's unique for each mineral. Minerals that have the same chemical composition but different atomic structures, different ways of atom packaging into the crystal lattice, are called polymorphs. One polymorph of zirconium oxide, ZrO2, that we observed in libya-desrt glass is called cubic zirconia, the kind seen in some jewelry as a synthetic replacement for diamonds. This mineral can only form at high temperatures between 2,250 degrees Celsius and 2,700 degrees Celsius. Another polymorph of zirconium oxide we observed was a very rare one called ortho-2 or O2. It forms at very high pressure, about 130,000 atmospheres, a unit of pressure. Such pressure and temperatures conditions provide us with the proof for the meteorite impact origin of the glass is because such conditions can only be obtained in the Earth's crust by a meteorite impact or the explosion of an atomic bomb. More mysteries to solve. If our finding is correct, and we believe it is, the parental crater where the meteorite hit the Earth's surface should be somewhere nearby. The nearest known meteorite craters, named GP and Oasis, are 2 kilometers and 18 kilometers in diameter respectively, and quite far away from where the glass we tested was found. They are too far and too small to be considered the parental craters for such massive amounts of impact glass, all concentrated in one spot. So, while we've solved part of the mystery, more questions remain. Where is the parental crater of the impact? How big is it? And where is it? Could it have been eroded, deformed, or covered by sand? More investigation will be required, likely in the form of remote sensing studies coupled with geophysics. This is from Elizaveta Koveleva, lecturer, University of Western Cape. This is republished from the Conversation under Creative Commons. This is from Science Alert, and it's on Unexplained Mysteries. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.